Now, let's start here with how to evaluate a definite integral using substitution for a trigonometric ratio, like sine and cosine. What we have to do? Let's do this one first here. Then we'll come back to that one. In this one here, as you see, we have the integration from negative pi over 3 to 2 pi over 3 for sine of x over square root of 2 plus cosine x. And they told me that you assume that u is 2 plus cosine x. So if u is 2 plus cosine x, so du, it will be 0 plus. Now what is, now here you have to be, to differentiate between the integration and the derivation.
Negative sign.
Distinguish between them. That's mean when you have to know that, or we have to make a table for you. Then the derivation of cosine is negative sign. Be careful. The derivation of cosine is negative sign. So I have du as negative sine x dx. Okay, let's come back here now. Now, square root of 2 plus cosine x, you have to substitute it with u. And then sine x, I cannot keep it as it is. But here, I know that sine x dx, or negative sine x dx is du. So I can replace it now with negative du. So instead of writing sine x dx, which is here, write it as negative du.
Teacher, what about the signs?
5?
It is negative x, and the du is negative sine x.
Yeah, I told you, write it as negative du.
Okay.
Here, this negative is like dividing by negative 1. So sine x dx is negative du. Now, so look at this one here. It was a complicated one. I changed it to simplest one. But since I change it, I need to change. This is a method too. That I need to change also the new interval. How? Here I have two. We have negative pi over 3 and 2 pi over 3. I want you now to use them and substitute it in u. So you will say u is 2 plus cosine negative pi over 3. And here 2 plus cosine 2 pi over 3. So the new value of u is 2 plus. Now what is the cosine? Oh, first that. What is negative pi over 3? It's like negative 180 over 3. Or I mean it's negative 60. So what is the negative cosine of negative 60? It is half. So I have 2 plus half, which is 5 over 2. This is, I have to write it where now? Here. Now let's come back to the second one. 2 pi over 3, it's like 2 times 180, which is 360 over 3, which is 120. So cosine (120) is negative half. So I have it as 2 minus half, which is 3 over 2. So I have now the integration from 5 over 2 to 3 over 2. Now look at here. Here I have from a large number to a small number, from 5 over 2 to 3 over 2. So I can rewrite it as integration from 3 over 2 to 5 over 2, but you have to change the sign. I mean, you keep it as du over square root of u. Because as you remember, as I told you first, the integration of the integration of AB is negative the integration from B to A. So here I use it, I can write it now as from 3 over 2 to 5 over 2 of du over square root of u.
Teacher, I didn't understand.
Which one?
Why did you flip it?
Here, no, you can keep it as it is. There's no problem. But I told you, if you want to change it as you start from the least interval to the greatest number here, if you want to flip it, to change it from least to greatest, you have to change the sign.
If you want, so I can keep
Yes,
it negative.
yeah. If you keep it, there's no problem.
Oh, okay.
Now, by now, until now, is it clear? Before I continue?
Yes, teacher. Please.
Yes, teacher.
Now let's integrate here. So I change my function into u. I change or I make a new interval that is related to u. Now I have to start to integrate now. Now then, this one here I have is like du or sorry. Before du here, I have it as u square root of negative, or u to the power negative half du. Integration, I can rewrite it like this. Then let's now integrate it here. U to the power negative half. U to the power n. So u to the power n plus 1 over n plus 1. That's mean negative half plus 1 over negative half plus 1. So we have half, or u to the power half over half. This 1 over half you can write as 2 square root of u. Now, from where to where? From 3 over 2 to 5 over 2. So let's substitute now. We have 2 square root of 5 over 2 minus 2 square root of 3 over 2. You can take 2 as a common factor here. So we have a square root of 5 minus 3 over 2, which is 2 over 2, 1. So the final answer here is 2. Here you can take 2 as a common factor, as I told you here. So you have it as 5 over 2 minus 3 over 2. Let's check this. That's what I want. Then after that here, no, I cannot combine them. Sorry, I make a big mistake here. Square root of 5 over 2 minus square root of 3 over 2. So let's now multiply them here. We have square root of 5 minus square root of 3. That's it.
Teacher, my answer is square root of 10 minus square root of 6. It's the same, right?
Yeah, yes.
Miss,
Yes.
can we do the integration first, then substitute, or we should substitute 2 times?
Do you mean the first method? Do you want to use the first method?
يعني في الأول عملنا substitute بعدين حطينا ال 5 over 2 to 3 over 2.
Okay.
يعني ممكن نعمل integration الأول بعدين نحطهم ولا؟
Yes, first you have to make the integration, then evaluate. Now here, I make the integration here. It was u to the power negative half. So it is u to the power half over half. or you can write it as 2 square root of u. Then you have to evaluate.
I mean the first time we substituted. لأن السؤال كان negative pi over 3 to 2 pi over 3.
Oh, okay, okay. Oh, okay, I understood. Now, what's your question?
يعني we should do this step ولا لازم يعني ولا عادي integration بعدين نعملها؟
Okay, you can use the first method that you can integrate with you. Then you can stop here. Okay, if you want to use the first method, like, see, now after we integrate, we found that it was 2 square root of u. So you can write it as 2 square root of 2 plus cosine x. Then this integration from, sorry, then from negative pi over 3 to 2 pi over 3. You can make it like this, then evaluate. That's what what you mean here?
Yes, yes.
Here, which is the first method. You can keep it as it is, change it to y, or change it to the original one, then substitute like 2 square root of, let's change 2 plus cosine negative pi over 3. Now, let's solve it now. If you want to use it by the first method, that's after I integrate, change it to the original one, then evaluate. So let's say we can 2 plus cosine 120, which is 3 over 2. So I have it as 2 square root of 3 over 2 minus 2 times square root, or we can say 2 plus cosine negative 60, which is 5 over 2. So then here we have it as, take 2 as a common factor, then square root of 3 over 2 minus square root of 5 over 2. Then you will after you finish here, let's make it as, if you want now, let's see. Darien, yes, it was negative 6 minus square root of 10 minus square root of 6. Because I I wrote it wrongly. Then I simplify. That's why. Then I simplify it wrongly. Here we stopped like 2 square root of 3 over 2 minus square root of 5 over 2. No, Dareen, I cancel 2 with 2. That I forget that we have a square root. Okay, that's why square root of 10 minus square root of 6 is correct. So here we have to simplify it. What you have to do, you have to say it's like square root of 3 over square root of 2 minus square root of 5 over square root of 2. Then here we have it as square root of 2 times square root of 2. Then they cancel them. So we have it as square root of 2 times square root of 3 minus square root of 2 times square root of 5. So which is square root of 6 minus square root of 10. That's okay, Nermeen?
Yeah, thank you.
Okay. Now let's come to this one here. Here now we have sine to the power 5 of 2x times cosine 2x dx from 0 to pi over 8. So sine 2x cosine 2x dx from 0 to pi over 8. Now, which one, sine or cosine? You have to assume that it is you.
Cosine.
Sine.
Try to use the complicated one. Sine. So assume you now is sine to the power 5 of 2x. So what is du now? it is 5 sine, the chain rule,
sine to the power 4.
sine to the power 4 of 2x
Okay,
times
not make
the
it 2
integration,
times.
the derivation of 2, which is 2. The derivation of 2x, which is 2, the chain rule. Here you have to remember the chain rule, how to find the derivation of whole here. So you have it as 10 sine to the power 4 of 2x. Okay, let's repeat it here. The chain rule, what did we have to do first? First, we say it's like 5 sine to the power 4 of 2x. So we integrate the things up. Then times the integration of the angle here, which is 2, the derivation, sorry, of the angle here, which is 2, times the derivation of sine. What is the derivation of sine?
Cosine.
Cosine.
Yes, cosine 2x. So now du is 10 sine to the power 4 of 2x cosine 2x. Okay. Here, after I solve it, I have cosine, which is u, then I have sine to the power 4. I cannot make it as so. Okay, let's make the assumption. So if if I keep it as like this, I have, okay, I can cancel cosine with cosine, but I have sine to the power 4 of 2x. I mean like this. If you write it here as u and cosine dx, you write it will be du times 10 over sine to the power 4 2x. Then how can I change sine to the power 4 to write it as u?
Can you say it again?
Okay, now here I find the integration, the derivation as du equal 10 sine to the power 4 of 2x cosine 2x. Then, since we say that, or we assume that sine to the power 5 2x is u, so I write it as u. And cosine 2x dx, it was like du over 10 sine to the power 4 of 2x. This is cosine 2x dx. So I will replace it now with du over 10 sine to the power 4 of 2x. I have u, but I have down here sine to the power 4 of 2x. Can I make it, or can I rewrite it using u?
Yeah, yes, teacher.
How?
I will divide by 2.
No.
We will put the sine to the power of 5 over the 10 sine.
No, you I can make it like it is square root to the power 5. I'm sorry. Then square root to the power 4 over 5, and I will continue. So it will be hard. So what I have to do, I want now to assume that sine 2x only is u. So here I want to think like you. If I use sine to the power 5, I found it's hard. So let me assume that u is sine 2x only without raised to the power 5. Then after that here, du, it will be 2 sine x cosine x, cosine 2x, because I find the derivation of the angle times the derivation of the outside, which is the chain rule. So du is 2 sine x sine, sorry,
Teacher, why 2 sine?
Did you remember the chain rule?
Yes, but the power is 1.
No, miss. When you said like cosine AX as an example, how will we find its derivative? You have to put A, the derivation of the angle, the derivation of inside, times the derivation of the outside, which is the derivation of
okay.
cosine. That's mean negative sine AX.
Okay.
Here we have the sum. Here we assume that square root so we assume that now u is sine 2x only. Then since u is sine 2x only, so du it will be 2 sine 2x. I find the derivative of the inside times the derivative of the outside. What is the derivative of sine? It is cosine 2x. So let's now come back here. Here, what did we have? Here we have integration from 0 to pi over 8. Then sine 2x, I replace it with u. So I will say u to the power 5 times cosine 2x dx. So what is it? If I divide du into 2 sine 2x, I get here cosine 2x dx. So I'll replace cosine 2x dx with du over 2 sine 2x. Then after that, here I have sine 2x. So what can I do? I can write it now as 2, but let me now replace sine 2x with u. Then I have it as half u to the power 4 du. Then I want to change the table, but before I change it, is it clear?
Yes, teacher.
Yes, the others, miss. Is it clear?
Yes, teacher.
So here I try to think like you. If I choose, I'll take sine to the power 5 as it is. It's hard to change it. So let me assume that u is only sine 2x. When assume it as sine 2x only, I found that it is easier now for me to change it. So it's like u to the power 5 times, then I will change cosine 2x dx using the du here. If you divide by cosine 2x the both term, by 2 sine 2x the both sides, I will get du over 2 sine 2x is cosine 2x dx. So I will replace du or cosine 2x dx with du over 2 sine 2x. But I cannot complete. Why? Because I have an x and u. I have two variables. I cannot integrate it. I must have only one variable. So what can I do? I will try to replace sine 2x with u. That I assumed it before. Then we can simplify it here as u to the power 4, then half u to the power 4 du. Then I have to change the interval. I have 0 and pi over 8. So let's write here. So since u is sine 2x, so when u is 0, I have to say sine 2 times 0, sine 0, which is 0. And when u is pi over 8, that's mean 180 over 8. So I have to say sine 2 times pi over 8. Or you can say sine sine pi over 4. What is pi over 4? This is 45. What is the sine of 45? It is square root of 2 over 2. So let me now change the interval for you from 0 to square root of 2 over 2. So I change now the function of the expression, the equation, sorry. I change now the interval. Let me now integrate.
Teacher,
Yes.
why it is not half u 4 plus 1 over 4 plus 1?
No, miss, I didn't integrate. Now I will integrate here. So it is half u to the power 5 over 5. You can write it as u to the power 5 over 10 from 0 to square root of 2 over 2. So here we have it as square root of 2 over 2 to the power 5 minus 0, so you can have the answer like square root of 2 over 2. Okay, so we have a square root. Oh, let's write it as square root of 2 over 2 to the power 5 over 10. So I have the answer as 0.1076. This is now the integration here. Is it clear?
Yes.
Yes.
Yes,
Okay.
teacher.
Now let's solve this one here. Tan squared x secant square x dx. They told me here now, assume that u is tan x. So let's assume that u as tan x. So du, now what is the derivation of tan?
Secant square.
It is secant square. So tan squared of x, I can replace it as u squared. Is it right?
Yes.
Then
Yeah.
secant square x dx, I replace it now with du only. Then from 0 to pi over 4. So I have to write now the new interval. When y is 0, when u is 0 and when u is pi over 4. When u of 0, when x is 0, so u, it will be tan 0. And when x is pi over 4, so u, it will be tan pi over 4. Now what is the tan of pi over 4? It is 1. And what is the tan of 0? It is 0. So I have it from 0 to 1. It's very simplest one. I have it as u squared from 0 to 1. So let's now find its derivative, its integration. I have it as u to the power 3 over 3 from 0 to 1, which is 1 over 3 minus 0, which is 1 over 3. Is it clear?
Yes, teacher.
Did you
Yes,
understand
teacher.
everything?
Yeah.
Have any problem?
No.
No, teacher.
This one is easy. I will skip it. Come here now. 6 sine x cosine times cosine x plus 1 to the power 5 dx. Now let's assume that cosine x plus 1 is u. Okay?
Okay.
Teacher.
So then du, it will be. Now what is the derivation of cosine?
Negative sign.
Negative sign.
Negative
Sine.
Bravo. So let's come back here now. 6. Now, here as you see, cosine x plus 1, I say that is u. So I will replace it with u to the power 5. And then sine x dx, I can replace it with negative du. So sine x dx, I can replace it with negative du. Is it right?
Yes.
Yes, teacher.
Then, so I will write it as negative 6 u to the power 5 du. Then let me now change the new interval. I will say when x is pi over 2 and when x is pi. When x is pi over 2, u it will be cosine pi over 2 plus 1. And when x is y, u it will be cosine pi plus 1. Now what is the cosine of pi over 2? It is 0 plus 1, 1. So the new interval here is u equal 1. And the second one, what is the cosine of pi? It is negative 1 plus 1, 0. So here I have u0. So I have it now from 1 to 0. Because the first interval pi over 2, I replaced with 1, and pi, I replace it with 0. Then after that, I will integrate. So let's make it as negative 6u to the power 6 over 6 from 1 to 0. They cancel each other. So I have as negative 1, 0 to the power 6 minus 1 to the power 6. So it's like negative 1 what I want? No, I'm here. So I have as negative 1 times 0 minus 1, which is 1. Is it clear?
Yes, teacher.
Okay. Now, look at this one here, and this one, and this one. These 3 questions, it will be your homework. Okay, I will post it for you on the discussion group.